Thanks of all, thanks for coming. We know it's not maybe the best hour. In Spanish, it's the hour for the siesta, to have some sleep. And thanks for choosing this talk. We will try to make you have a good time and to show you something that maybe you can use or maybe not. And it's only the hype of the title, so let's see. We will start talking about a company that started to grow a lot until a moment that the development management start to be really, really complicated. It becomes really a chaos. So after we will present the different changes that we have in that moment and also the solutions that we made for these changes. How talk is cheap, we will show you a demo where we will start to deploy one application from scratch until our production environment. And finally, we will talk about the lesson learned during this journey. Let me introduce myself. I'm Xoan. I work at Zscaler, a cybersecurity company that maybe some of you know, maybe some of you don't know. We are really well known for the VPN products that maybe some of you suffer as, or let's say the company, because I don't work in that product, so don't blame to me for that. And I used to work at Dog Planner with Manu, where we made this happen. So let me pass the turn to Manu.
Okay, hello, everyone. My name is Manuel Cañete. I work as a site reliability engineer at Dog Planner and platform engineer. Here you can find my LinkedIn account in case you want to contact me after the talk. Here in Germany, the Dog Planner group has a company that was acquired, I think, 1 year ago, or 2 years ago. I think it was the last year. That is Yamida. Maybe you know better the name than Dog Planner. But let's start. Let's start talking about what was our starting point. As a fast-growing company, we were experiencing a rapid expansion with many new projects and many newcomers joining us, joining our team and developers team every week. So this growth, while exciting, brought with several challenges that needs to be addressed to maintain our efficiency and productivity. So let's go with the challenges. One of our main challenges was the release process. Our CI/CD pipelines were non-standardized. So each team had its own way of doing things. For example, we had some teams using CircleCI, others GitHub Actions, others were using Azure DevOps, and others even using other systems like Buddy. It was a bit mess, and each team had its own way. So another challenge related to the release process was that we had the build process tightly coupled with the build process tightly coupled with the application configuration changes. So when we had to change something in configuration, like for example, increase the CPU of a workload in Kubernetes or the memory, we had to run the same pipelines that we were running for building the Docker image or releasing a new version of the application. So it was terrible and it was so inefficient. And let's see an example of how our release process used to be before the changes. Developer, in this case, he started the flow, making a change to the application repository. And at the same time, an automatic build was triggered in our CI/CD systems. It was a bit different depending on the system, but more or less, this was the same approach in all of them. So after building the Docker image, the new version of the Docker image, the new tag, was uploaded to the Docker Hub. And then we were upgrading our Helm releases with the pipeline in Kubernetes. And Kubernetes downloaded the new image, the new tag, from Docker Hub and deployed the new version, finishing the release process. This was to release a new version of our application. But how was the configuration changes? If we want to increase the memory, for example, or make a change in the ingress for the URL or whatever, we had to execute exactly the same pipeline because we had both very coupled. So if we wanted to increase the CPU, we had to spend 10, 15 minutes, or it depended on the application, to reflect these changes on production. So that was very inefficient, and Xoan will show us later how we solve this situation. So another of the main challenges that we had was related to the lack of autonomy among our development teams. So the process of setting up new projects was very complex because developers had to make a lot of requests. The platform team had to make a lot of manual actions. It was very complex. It required a lot of tickets, a lot of effort. It was really complicated. And these manual actions and the dependency between the development teams and the platform teams increased the friction among both teams, the development teams and the platform team. And for development teams was really difficult because some of them were really frustrated because they wanted to move faster and they wanted to have their control over their applications. And it was, at that point, it was impossible for us because they had to ask for something, create a ticket, the platform team has to do it, so they had zero autonomy at that point. So this was, for example, an old college waiting for a new database to be created by the platform team. This is a real example. So another, scalability was also a major issue. We were overwhelmed with many requests, with many tasks. The platform team also was very frustrated because this reaction for this task is not productive, and it's difficult to keep up with the demands of the growing number of teams and projects. And we needed a solution to distribute the work among our team and the development teams. So we want them to be more empowered, to empower them, and to be able to manage their own deployments. So now we are going to talk about what was our proposal. Xoan is going to start talking about how we solve the issues related to the release process.
Thanks, Manu, for the introduction. So now let's focus in our proposal to the different problems that we already know. First of all, we quickly realized that we can continue with the initial release process that we have. Now, especially, we want to make a change in Kubernetes configuration, not only in Kubernetes configuration, taking into account that an environment variable is also in the config map or in the deployment manifest, is not worth to build the application itself, build the Docker image. That is really a process that can take a lot of time, especially if we were developing in .NET and PHP. They are not the best languages in terms of you need to build again the image. So after researching and making some testing, we realized that we need to go for the GitOps path. And what is GitOps? GitOps is a set of practice to manage the infrastructure and the application using Git as a single source of truth. and is based in 4 principles. The first is the declarative. What this means? This means that a system managed by GitOps needs to have the desired state in files that are declarative itself. This means YAML files or JSON files that they don't need to have an integration or an iteration with other parts, like, for example, Terraform, that you need to execute the code itself. No? The best example is thinking YAML files that you need to deploy in your cluster. The second principle is that these files need to be in a system that can guarantee you the versioning and the immutability of that files. This is because, as GitOps, you can infer the first part. Normally, you are going to use a Git system because it's an easy way to version these files and also to get track of every change, how this change makes in the part of the deployment. And also because it simplifies a lot the rollback, because we are using it. We can go to the previous commit and deploy again. No? And also, these GitOps have to have some agents that are going to be making a pulling process continuously to the desired state, that is the files in the repo, and they are going to be continuously reconciled, and this means that every time there is a new change in the repo, it's going to be reflected automatically in the cluster. And also taking into account that if someone by hand changes something that is not in the repo, this agent, again, is going to reflect the change and is going to delete the changes that are not reflected in the repo. So let's focus now in the following scheme. Again, a developer made a change in the Git repository. This GitOps operator is going to pull the changes that are made in the repo. And automatically, this GitOps operator is going to reflect the change in the cluster. So now let's focus on how we implement this. First of all, we deploy ArgoCD. We didn't have any GitOps tool, so we decided to go with ArgoCD. The reasons, let's say, that was the best for us, especially because we like the interface that the Argo has, and especially the user experience. It's really easy to start using it, and especially because we start to deploy ArgoCD and allow developers to use, because we want to, as Manu explained, empower them. And ArgoCD is a tool that with a really good user experience to know what is happening in Kubernetes cluster and in your application itself, deployed in Kubernetes. And following the GitOps paradigm or the best practice of GitOps, we start to move our Kubernetes configuration that was in the repository, in the code repository, to a monorepo where we only store the configuration files for Kubernetes of each application, having one folder per application. This is to directly decouple the build process from a change in the code, like a fix or a new version, from the Kubernetes configuration. And as Manu said, we were using different tools without a standard process, and especially without having a standard tool. So we decided to go to GitHub workflows, and also because we want to have a standard, we start to define our GitHub reusable workflows. These are, let's say, templates where you define the different steps, the different actions that you use with specific versions of the actions, and you only put some inputs to be passed to the template. And this is especially useful if you want to have a standard procedure, for example, build your image, and you only need to say, hey, give me the path where is the Docker file, give me the registry where you want to put this image, and all of these types of things. So we start to have these workflows. And how is the final picture? Here we can see that it's a little bit different, as Manu explained before. Now, a developer made a change in the application repository, where is the code of the application. So it triggers a Docker image build that is going to be pushed to the Docker registry. And after that, following a continuous deployment approach, we will trigger another workflow that is going to get this new Docker image and is going to update in this monorepo that I mentioned the new image tag, and after that, Argo is going to pull this change and is going to deploy in the cluster or in the clusters. And there is the other path. We can directly go to the repo because we want to change the request, the resource, or even an environment variable, and we don't have to build the image again. Directly, Argo is going to get the change and is going to roll out a new versions with the change in the cluster. And now Manu will explain us how we increase the autonomy of these developers.
Okay, so another key aspect of our proposal was to increase the developer autonomy. So to do that, we started creating some automation in the creation of components, like what is well known as golden paths, to create some components from scratch, to reduce this cognitive load and this so many tasks that the platform team had to do. So also with this automation of component creation, we started adding to these automation pipelines some best practices and good standards that were defined by the organization. So by reducing the need for these manual actions and providing these self-service tools, we enabled our developers to move faster and to empower them to do all the things by their own. So what we wanted was to create some golden paths, some workflows like this one. So we wanted to create first the Git repository. Also, the infrastructure as code pull request that were created to deploy the dependencies of the application with Terraform. Then create also in the same automation the pull request for the Kubernetes configuration. This is what Xoan was explaining for Argo to reflect the changes in production. Then here we have written down an example of configuring Kibana, but it's an example for dependencies that cannot be configured using infrastructure as code, for example. So we needed also to send notifications to the platform team, at least to be informed that a new component was created. So this was a big picture about how has to be our pipelines for automation, the creation of new components. And let me check one thing. Just one thing. Okay, I think, okay, we have mixed some slides. I'm going to start first with this one. But so how we did it? How we improved the autonomy of developers? So we were checking what was the best option, and we decided to create our own internal development portal using Backstage. Backstage is an open platform for building developer portals. So it was developed by Spotify and donated to the CNCF. So it's open source. You can go to the repository and deploy an instance of Backstage in your cluster, and that's it, more or less. We will see later what are the cons. But why we decided to go with Backstage? Because Backstage has some features. The main features are maybe the catalog, the software catalog, where you can find the components of your company, or the tech docs, where you can find the technical documentation for developers. But the main component that, for us, the main component was these software templates. These software templates provide self-service boilerplates that were what we needed at that point for creating these golden paths. So I'm gonna come back to the previous picture. So let's start here. And so how was this final picture introducing Backstage? The flow started with a developer creating an application in Backstage. So the developer was to the UI, went to the UI, filled some parameters in Backstage, and executed the template, the software template. So this software template created the repository and the pull request. Then we had to, at that point, we had to do some manual changes because we were using Atlantis, that is a tool related to, it's like an abstraction for Terraform to execute the Terraform plan and apply in pull requests. So at this point, we had to still do some manual actions, but were really reduced. And then, after that, ArgoCD was already prepared to synchronize the configuration of Kubernetes that was in the repository, in the monorepo, synchronize it to the cluster. So at this point, we have a production-first approach from scratch to production, or the environment more similar to production that can be staging or testing or whatever. So we can have this approach in just a few minutes. It depends how do you have your flow, because you maybe need to create some databases and it takes more time, or maybe something related to AI that it takes more time, but you reduce all the blockers and all the manual actions that you have to do before having this golden path. So let's go. Oop. Okay, let's have a quick look how a template is defined in Backstage. If you go to Backstage or you are used to work with Kubernetes, you can see that all the objects in Backstage are defined in a similar way. They use the same definitions like Kubernetes objects. So the templates are defined in this way. There are some main sections, like, for example, the kind that has to be template, because Backstage also handles other types, like resources or components to define your APIs, your services, or your databases. But in this case, it's going to be template. And it has other sections, like the metadata, where you put, for example, the description, or the name, the title. And the main section is the spec one, where you can define the parameters, the steps, and the output. The parameters are the inputs that the developer has to fill in the UI, and it is auto-generated. So it's a form auto-generated that is defined in YAML, and it is rendered using a React library, that is React schema form. So you can put there, for example, that is a Boolean, and it is rendered like a checkbox, or it is a string, and then it's a text box. So it is so powerful and so extensible. And those parameters are the inputs of the steps section. And the steps section is like other pipeline system, like, for example, imagine GitHub Actions as similar. No? You can define, for example, there, actions to fetch the code and replace with the inputs that the developer was introducing in the UI. Or another step to create a repository, another one to create a pull request. So there will be the steps to define this golden path, this software template. And the outputs are the information for the person that executes the template. For example, a link to the resource that is created, a link to the documentation, or other information. Okay, so as talk is cheap, Xoan is going to start showing you a demo, a little demo.
Okay, so as Manu mentioned, let me one moment. I need to. Okay, so let me check now. As you can see, I want to show that it's a real cluster that we have here. It's in GCP in this case. You can see there are relatively the nodes. So we have ArgoCD deployed from one side, and in other side we have Backstage deployed. So this is the catalog that is other powerful feature of Backstage. That is to get track of the repository that you have and the different things related with the repo itself. So let's focus now on the templates. There is a powerful option that is this one, that is to template inline the software template. And with this only, I want to show an example of what Manuel already mentioned. Here we have the parameters that are in this case only the name that we will use for the component name, that is what we are stored in Backstage, that in this case will be the same as the repository name. And also the location where we want to create a repo, that is going to be a GitHub repo, and we force our organization that is on my platform. So here we can view the steps. The first one is going to get in this content folder that is a boilerplate for create a repo following the standards. We have the GitHub workflows and all these things, and the catalog info, that is the file where Backstage is going to get the metadata to consider a project inside this catalog that I already showed before, and the ArgoCD apps, that is, as we are going to see later, is where we are going to create these files in the GitOps, following the GitOps approach. In this case, we are going to create some manifest for terms of simplicity. So, and finally, the outputs. In this case, will be the repository, and also the PR. So if we go directly to create the repo, the component, let's say, I'm going to say stackconf.
Just to mention, the other screen was just the dry run. It's like you can execute it, but it's not gonna mutate anything. Everything is done in this screen. The other one is just to help developing templates. But
yeah, if we push the run button in this case, it will show how the change that will be applied, how these render files, how will be rendered these files. So now we are going to put, as we already mentioned, the repo and the component name we will use the same in this case. And now is the summary, that really is the name of the component and also where is going to be created the repo. So if we push the create button, now we can show the logs that are going to be rendered by order. Here maybe it's not things like that, but they are going to be executed in the order. It's a sequential steps. If any of them fail, it's not going to continue to the next one. And here there are three important outputs, or maybe two important outputs in this case. The first one is the repo that is already created following the standard that we defined. Here we can see that it's using a reusable workflows. We can see here. And now it's going to build the image. And now let's focus in this monorepo. We create in two folders. The first one is the application. ArgoCD is managed by what is called application. Basically, is where you say to Argo, where are the manifests for each application. Here we can see that it's going to be in the repo URL of the same repo, but in the path that is called configuration and the name of the component. So after, we can check that is a basic deployment and ingress, also to create a certificate and a service to connect the deployment. So now that this is created, it was a current condition, sorry, because as I mentioned before, in the flow explanation, this failed because this is trying to update the path in the path of the new application, the image tag. I was talking, so I didn't merge this file, so failed because this didn't exist. But if we only run the failed jobs, we can check now how this will work. And yeah, now we can. This is using a tool that we made. It's a public repository that is her repo updater. That is basically to interact with this kind of repos. So now, if we come to these ArgoCD apps, we can check here that is going to find all the apps that are in this folder, no? In this path of apps. That, if we check here, in the apps, there are the apps defined. And in this case, we created this stackconf demo. And this is also a .NET simple application. So if we come here, and if we refresh, it's going to be done every 3 minutes. Now we can see this stackconf demo that is syncing and is creating the resource. So now it's going to be created the certificate. It's using external DNS, so it's going to create a record in the domain that we have. That is, as you can see, on my platform.org, where is also deployed the other tools. And probably in few minutes is going to be the certificate ready. So it's not only hide the title. Maybe in 5 minutes is deploy the application. It's also because here we are not creating an infrastructure resource for terms of simplicity, and because it's a demo.
So maybe while the certificate is being created, I'm gonna make some changes and prepare some changes in a pull request, just to see later how the changes are reflected after the application is created.
Yeah, for sure.
Let me I'm gonna I go to the repository, for example, for the stackconf demo. I'm gonna open Visual Studio Code here in the browser, just to make some changes. I'm gonna create a change in the application. It's a simple application. It's just for the demo. It's a .NET application that exposes a URL for the weather forecast. It's the demo of the .NET team. So we are gonna change it. We are gonna put, for example, stackconf. So this one, and I'm gonna change also the documentation section, just to show you later how the technical documentation is, if we have time.
Yeah, so as Manu is mentioning the technical documentation, there is another powerful feature of Backstage, that is the tech docs section. That is basically tech docs is MK docs, but with steroids, let's say. No, it's basically Markdown, but using only Markdown, you can create a lot of, for example, snippets of code and this type of logs that after is deployed you can see, and basically use a bucket to use like a CDN to serve the content. No, and as following something similar to GitOps, is going to create a folder for each component, and it's going to create the assets directly there. Okay. And Backstage, again, is going to serve directly this content. It's really useful because you can create even mermaid diagrams following only Markdown code. It's what is called tech docs because it's really useful for technical documentation.
Yeah, as we see here, the application is already created, so the certificate is already created. So if we go to Swagger, for example, we can see that it's a valid certificate, and we have here the URL of weather forecast already deployed in just a few minutes in the Kubernetes cluster. So if we go now to the repository here and to Visual Studio Code, and we do here whatever, so we change demo change. I'm going to push directly now for the demo.
Yeah, don't do this in your house, especially in your companies.
And now if you go to the, no, not this one. Let me go to the repository of the demo. That is this one, stackconf demo. So now in the actions, we can see that there are two workflows that are running. One is for building and pushing the image to the repository. And this one, if you check it, is building the image, and then it's going to update the tag of the image in the other repository. And at that moment, ArgoCD is going to synchronize, it's going to reflect the changes directly into production. So it's going to be automatic. So let's see which one finished first to explain it. Okay, so also the tech docs. So all of these workflows are based on these reusable workflows. All of this is public. So if you want to go to the GitHub, to our GitHub organization, you can check the repositories and the code of the GitHub reusable workflows.
Yeah, maybe if you can go there.
Okay, here the change is already done, so it has been updated. So if we go to ArgoCD, I say it has to be, okay, it's being updated right now. So once the post is ready, it is ready now. If we reload the page, we can see how the change is updated in the application. Yeah. So we can see the two workflows, one for automation, the creation of new components, and the other one for this following standards to update and to follow a continuous integration and continuous deployment approach from scratch. From the first day, following a production first approach. This maybe is not production, but can be the environment most similar to production.
So now, if you go to the Tech Talks section in the component that we already update, now we can view this block that Manu made and it's served directly from the bucket.
This is another good feature of Backstage. You can have your Markdown files using, it's like mkeydocs. It's an abstraction of mkeydocs, but it's more or less the same with the same features, and you can add the same plugins that you can have in mkeydocs, and it's the same. You can follow this approach, and you can follow the same CI pipelines for updating the documentation, the technical documentation. And yeah. Okay, so
now after showing the demo, let's return back to the presentation and let's focus on maybe some of most interesting things, that is the lesson learned during this journey. The first is the GitOps part of the GitOps side. What is worth the effort? Definitely yes. It's not a big effort. It's not like migrate from another cloud that we already we can do a talk about this because we made like 3 big migrations before this, talking about cloud and also moving to Kubernetes the application. But in the terms of GitOps, yeah, it's worth the effort because it's not a big effort. We were already in Kubernetes, and really it's going to speed up a lot the deployment process, especially because if you want to change an environment variable or if you want to change, as Manu mentioned several times, the resource part, it's only a change, and ArgoCD is going to deploy in one cluster or in several clusters because Argo is designed to be connected to several clusters and deploy only in what you want using label and selectors. And also, it's worth separate the config from the application. Yeah, definitely yes. Because especially if you are using the GitOps and if you are using ArgoCD, ArgoCD is going to have a better performance if you are pulling to the same repo with different paths than pulling to a lot of repos. No? Imagine if you have hundreds of applications. And also, this is because if you're using GitHub or GitLab, in each event related with a commit, commit is going to tell you where is the path, where is the change. No, especially in the demo that we show, the path is directly related with an application. So ArgoCD only have to do the refresh of the application itself, no refresh all the application. That is a lot of work to do. But bad news, if you are using Bitbucket, as in my case now, in CScaler, Bitbucket don't have this part. You don't have them in the metadata of the event, you can know. You have to refresh all. Now ArgoCD is improved a lot. It's prepared to do sharding between the replicas per having one dedicated for each cluster that before you can do. And also, there are other techniques, like for example, if you are able to do this with GitHub or GitLab, in the annotation of each application, you can pass the path where you want to check where it changes to update the application. And now, let's pass the turn to Manu.
Okay, so related to Backstage, and if it makes sense or not, and when, for our use case, it was worth deploying Backstage, but you have to be careful if your company is small, because it required a lot of effort to maintain, because you deploy Backstage as a new application written in Node.js and React, and you have to have at least people with that knowledge in your company. If not, it's going to be difficult to keep up to date Backstage and test everything. Is a bit difficult. In our case, we are more than 100 developers, and it made sense. But if you are less than, I don't remember exactly how many developers Backstage recommends to have before deploying it, but I think it's, if you are less than 100 developers, it makes no sense. If you are if you have a small teams of developers, like 30 developers, it makes no sense, because it's going to be a bit chaos. But in our case, it was worth, because it reduced a lot of work for the platform team. So yeah, I mean, we are a bit of time, so I'm gonna finish. And that's all. And so if you want to give us feedback, here we have a QR, and now is the time for questions you have. Thank you.
Thank you both. Any questions? I will come to you.
I have a question to Backstage. So is it also possible to later do updates to the repositories? Let's say you created 100 repositories for 100 new applications. Now you say, oh, I want to roll out some addition. So the new applications would get it, but what's with the old ones?
No, I mean, not out of the box. If you deploy a lot of applications and you want to keep all the applications up to date, you have to follow other strategies. Okay. Our strategy, for example, was to create these reusable workflows in all the clusters, version it. I mean, if the version of that workflow change, the application is going to be updated. But that responsibility is not for Backstage.
Okay.
At least not at this moment. Let's see in the future.
Thanks.